So we also want to be able to find the antiderivative of e to something. And then there's this one special case of 1 over x, which we'll get to as well. So if we think about, okay, whose derivative is 4e to the 4x? If we first just think about, okay, if we have our function e to the kx is what we did often, and we took the derivative of that, we got e to the kx times the derivative of kx, which was this k. So it was like k e to the kx. So for example, if it was 4e to the 4x, then the original function would have been e to the 4x. If my derivative was e to the 5x, it would have been e to the 5x, but if I took the derivative initially, I would have that 5 in front. And since I don't have an original function, I would have to divide by 5 to get rid of it. And again, I should be putting my plus c. So we'll come back to this number 3, but the rule for e to the kx, and these are really the only exponential functions we're going to do in this class, is that it's itself, and then we divide by whatever k is, and then put plus c. So for example, the integral of e to the 7x would be itself over 7 plus c. Okay, so you can either think of it as over k, or sometimes I think of it as it's over the derivative of the exponent, which is 7. So that's the rule for the exponential. Now there's this other special case of 1 over x. So if you do what we tried to do before and make this x to the negative first, and you try to use your power rule. So -1 plus 1 is 0 over 0. This should raise some red flags because you can't divide by 0. This is undefined. And so some students are like, okay, I'm done. The antiderivative indefinite integral doesn't work. But that's not the case, because we do know a function that has this as its derivative, and that was the ln of x. So the derivative of ln of x was 1 over x. So the antiderivative of 1 over x is ln of x plus c. Now we write it as ln of the absolute value of x plus c. That's really the rule for when we take the antiderivative of 1 over x. Again, 1 over x is the same as x to the negative first. So if you ever see that, that's also the integral is the ln of the absolute value of x plus c. The reason for the absolute values is we want the domain of the antiderivative and the derivative to be the same. So 1 over x looks like this graph. And this domain is all real numbers except x can equal 0. This graph is the natural log of x, and this domain is x is greater than 0, so they don't match up. So in order to get them to match up, if we add that absolute value of x on, then this domain is the same, where it's all real numbers except x can equal 0. The reason is you can't plug a negative into the natural log, it gives you an error. But as soon as you put that absolute value, you can plug every number in except 0, which matches that domain. So that's the reason that's the absolute value. Just remember to put it when you're writing the answer. So in general, if I have my derivatives a over x, if I want to take the antiderivative or indefinite integral, what we do is we put the a in front, and then it becomes the ln of the absolute value of x plus c. The reason is that it's kind of like derivatives. You can pull out the constant and just take the integral of this function, which would be, if you pull out the a, it would be a 1 over x. And so again, that would be a, and this integral is that absolute ln of the absolute value of x. So the integral of 6 over x dx, that would be 6 ln of the absolute value of x plus c. Okay, make sure it goes in front of the natural log. It does not go with the x inside of it. And that's the rules for the exponential function e to the x, and then the special case of a over x or 1 over x.